Good morning, everyone. I, Anupam Singh, Director of State MR Jaipuria School, Patna, welcome you all to this wonderful workshop titled Reach for the Stars, an international workshop on astronomy. It is my privilege to welcome Dr. Rachel Smith, Dr. Murthy Gudipati, Miss Melanie Crowson, Miss Meghna, all the students of Jila Parishad High School, Kaza, Andhra Pradesh, students of various Bihar government schools, and students of State MR Jaipuria School, Patna, parents and members of Team Jaipuria. I heartily welcome you all to this international workshop on RESTEM Initiative, Reach for the Stars. Astronomy is a science that seeks to explain everything that we observe in this universe, from comets and planets in our own solar system to distant galaxies and the echoes of the Big Bang. By studying the cosmos beyond our own planet, we can understand where we came from, where we are going, and how physics works, which are impossible to. In astronomy, the entire universe is our laboratory. Our interest of Jaipuria School in this subject is further fueled by the fact that our school is located in Khagol area. Khagol is a variant of Khagol, which is astronomy in English. It was the workplace of the Indian astronomer and mathematician Aryabhat. Aryabhat was born in 476 AD. Very young age, 23, he wrote his monumental work Aryabhatyam. Aryabhat is credited with the invention of deduced the approximate I, and in Aryabhatya, the astronomical observations by this great mathematician is absolutely ingenious. He described the heliocentric model where the Earth revolves around the Sun, 1,000 years before Copernicus proposed his theory in 1543. Lying in the vicinity of Khagol, about 25 kilometers from our school, is another village named Taregna. Taregna is perhaps the oldest observatory and laboratory of Aryabhat. Aryabhat had camped here to study celestial bodies. The word Taregna comes from the ancient Sanskrit word that is Tara Ganana, that is calculating stars. Currently lying in oblivion, Taregna offers the best site for eclipse and was in national news when lakhs of scientists and students made it an academic tourist site to view the total solar eclipse on July 20th, 2009. The state government has now decided to develop these locations to serve as astro-tourist attraction as well as provide adequate exposition to his life, working and contributions of Aryabhat in the field of mathematics and astronomy. This global seminar has been designed by Meghna with an objective to ignite passion for astronomy among all students by inspiring and establishing connections on a global scale, working with researchers, teachers, and mentors. To give you a quick glimpse of the entire workshop, our team of Jaipuria School teachers have already conducted a 4-day session on astronomy, wherein the students have been exposed to some basic concepts of this vast field. This pre-workshop activity was conducted to ignite interest among all students and make it more interactive. Pre-activity involved science teachers conducting informational sessions and learning assignments for the entire class. Students' participation was exemplary, and they have made some unique PowerPoint presentations and videos explaining what they understood about the topic. Some students also made telescope at home using mirrors and lenses. What they created made us wonder about the unimaginable potential that lies within every child. I hope today's webinar will fuel the fire that lies within every child, and we'll hope that it will address all their queries. May I now request Meghna to take the webinar forward. Meghna.
Thank you, Ms. Anupam, for all the introductions. Hello and welcome to this webinar, RESTEM Initiative, Reach for the Stars. My name is Meghna Chamardi, and I am a Girl Scout Junior with Girl Scouts NC Coastal Pines. The goal for today's webinar is to inspire you and explore the vast field of astronomy. To start with, let me give you a brief introduction to RESTEM Initiative. RESTEM Initiative, which stands for Rural Education STEM Initiative, was started as a part of my Girl Scouts Gold Award project. The mission of RESTEM Initiative is to minimize the rural to urban educational divide by enhancing STEM education for the rural community, preparing, motivating, and inspiring the students for real-world education and applications in related STEM occupations and fields. Inadequate rural education is an issue faced at varying degrees by every nation in the world. To add to this, the current pandemic has created additional hurdles and barriers to provide quality education. RESTEM Initiative is working to mitigate this issue by creating hands-on STEM kits for students in rural and underserved communities and areas, and is reaching out to them through webinars and workshops. To begin, we will be presenting a quick video that goes over some cool astronomical concepts and includes a fun activity that you can try at home.
A system of lines is used to find the location of any place on the surface of the Earth. It is made up of two sets of lines that cross each other. One set, lines of latitude, consists of horizontal lines. The other set, lines of longitude, consists of vertical lines. Although these are only imaginary lines encircling the Earth, they can be drawn on globes and maps as if they actually existed. Using a sundial, we can figure out our latitude. Every sundial is made up of two parts, a gnomon and a dial. The gnomon serves as a pointer for the sundial, whereas the dial serves as the circular surface of the sundial. First, we are going to determine the latitude of your location, using a paper plate as a dial, a rod as a gnomon, and clay to keep everything together. First, take the clay and stick it to the center of the paper plate. Then, take the rod and stick it in the clay at an angle. At 12 o'clock, when the sun is directly overhead, take the paper plate with the clay and the rod outside. To correctly use the sundial you just created, the gnomon should point north. Adjust the angle of the rod until the shadow of the rod is a thin line. Then, take a protractor and measure the angle that the rod makes with the paper plate. This angle is the latitude of where you are. The angle between the visible horizon and the North Celestial Pole, marked almost exactly by the North Star, Polaris, is your latitude. When you are measuring the angle between the gnomon and the disk, you are also measuring the angle between the visible horizon and the North Celestial Pole, because the gnomon was set to point north at the North Celestial Pole. If you set up the gnomon to point north on a clear night, sighted across the top edge of the gnomon, you should be able to see it pointing at Polaris, the North Star. Polaris is part of the Ursa Minor constellation. The Ursa Major constellation is located near the Ursa Minor constellation and is known as the Big Dipper. Some other constellations that you might be able to spot on a clear night are Gemini, Orion, and Taurus. When locating things like constellations or planets, astronomers measure the difference in the angles of the two things in degrees. This is known as the angular separation between two objects in space. The angular separation of any point on the horizon and the point directly overhead, the zenith, is 90 degrees. Halfway from the zenith to the horizon is 45 degrees. Smaller angles are a little trickier, but our hands and fingers are remarkably accurate and convenient measuring tools. When you hold your hand at arm's length, you can estimate angles like this. Stretch your thumb and little finger as far from each other as you can. The span from tip to tip is about 25 degrees. Do the same with your index finger and little finger. The span is 15 degrees. Clench your fist at arm's length and hold it with the back of your hand facing you. The width is 10 degrees. Hold your 3 middle fingers together. They span about 5 degrees. The width of your little finger at arm's length is 1 to 1.5 degrees. Let's try this out with a scaled image of the Big Dipper. Holding your hand in a fist, arm's length away, approximate the angle between the two lines highlighted in red. By doing this, we can approximate the angle as 10 degrees. Hold your hand with your pinky finger and pointer finger out at arm's distance away and approximate the angle between the two lines highlighted in orange. By doing this, we can approximate the angle as 15 degrees. Holding your thumb and pinky finger out on your hand at an arm's distance away, approximate the angle between the two lines highlighted in yellow. By doing this, we can approximate the angle as 25 degrees. Sometimes astronomers need to use increments smaller than a degree. Astronomers measure angles smaller than 1 degree in arc minutes. There are 60 arc minutes in 1 degree. The symbol for arc minutes is a single apostrophe. Looking at the moon as an example, it is about 31 arc minutes across. Each arc minute is divided into 60 arc seconds. Taking Jupiter, for example, it is 50 arc seconds across an apparent diameter. A good optical telescope in steady skies can resolve down to about 1 arc second.
I hope everyone learned and enjoyed something from that video. Moving on to the speakers for our webinar today, Ms. Melanie Crowson from the Pisgah Astronomical Research Institute will be our first speaker, followed by Dr. Rachel Smith, Head Curator for the North Carolina Museum of Natural Science's Meteorite Collection, and concluding with Dr. Murthy Gudipati, Principal Scientist at NASA's Jet Propulsion Lab at the California Institute of Technology. Ms. Crowson was unfortunately unable to be here with us today, so we will be showing an interview I had with her earlier this week. Ms. Melanie Crowson is the Education Director / Astronomer at the Pisgah Astronomical Research Institute. She led the SEBS chapter, including the aforementioned meteor sighting data collection, group-wide astrophotography with the Celestron USB telescope camera, and usage of a virtual telescope for studying a comet. Without any delay, here is the interview with Ms. Crowson. Hi, Ms. Crowson. Thank you so much for joining me today. So I wanted to ask you a few questions for the students in the webinar who are joining us today. So the first question I wanted to ask you is, what interested you to get into this field of astronomy?
Gotcha. Well, I feel like I've always been interested in astronomy. I remember being really interested in the sciences when I was like 5 or 6. And then astronomy really caught my eye probably about 7. I've always had this interest in just science, the things that were really far away, really exciting. I had a lot of different sources of inspiration. My parents were some of them. They're very encouraging, very supportive people that encouraged my interest in whatever it was that kind of caught me, My dad used to work several jobs at the same time, and one of them was an overnight paper route. And so once in a while, he'd let me and my sisters go with him at 2 a.m. from like 2 to 5 a.m. and deliver papers around the neighborhood. And he's driving at like 10 miles an hour. So, I mean, the windows were open and we'd just stick our heads outside the window and just look up at the stars. And it was totally dark. Everybody had their lights off because they're all in bed. And it was just, it was kind of fun and magical, And so that was really good. So that was a great inspiration. Star Trek was on at the time, so there were different TV series of Star Trek, and they weren't like the Star Trek now, where it's very exciting. It was a little less exciting and a little more science, less action and special effects, and a lot more science. And the whole story would just focus around like this group of scientists on a spaceship traveling through the universe, and they'd come across a star, a planet that was scientifically puzzling, and they'd spend the whole episode just working as scientists trying to figure it out. And that was really neat. It was very different. It was very exciting. At least to me, that was very exciting kind of thing. There was also a book that I had read when I was like 14 called Galileo's Daughter by Deva Sobel. And that was a really inspirational book, I thought, too, that really helped solidify my interest there, too, because the book kind of brought to life the historical figures of Galileo and his family and the history of what was going on at the time and involving it deeply in science. And it just really came alive for me. The final thing I'd say of what was really inspiring for me was I made a telescope with my dad. We built a telescope together when I was 15 and finished it when I was 17. And it's still my favorite telescope, and I still use it all the time. And that was just a fantastic hands-on experience. So I've had lots of sprinkled interest, inspiring events happen. That have all been pretty guided there, and it's been awesome. I'd say I'm really blessed.
Yeah, I mean, I think that's one thing that's really cool about astronomy, is that it's kind of just like things that you see every day, like looking at the sky and just random activities. So you work at PARI, which is a research institute, astronomical research institute. So at PARI, you interact with different levels of students. So what advice would you give to students here today who are like interested in astronomy or just curious about it, how they can explore that?
Gotcha. One of the biggest things I'd probably say is to be passionate and hang on to the excitement. There's definitely some mundane parts of pursuing astronomy. If they decide that they want to get into the sciences, beware, there are some mundane parts. Some of the stuff you do in research is just repetitive, click, click, click for several hours. It can be kind of mundane. There is a lot of math involved. There's a lot of math courses to take, but hang on to the excitement, hang on to the passion, because that's ultimately what makes it so great at the end of the day. Anything's going to have its slower parts or less exciting parts, but don't let that distract away from it. Hang on to what makes it really exciting, and whatever is fueling that excitement, just follow that to the brink of wherever it goes.
Mm-hmm. So I guess just to finish it off, so obviously PARI is an amazing resource for people to visit, but if there aren't places that these students can visit nearby, what kind of activities or things can they do by themselves just to further their interest in astronomy?
Gotcha. Probably one of the best ways would be to learn the constellations, learn the nighttime sky. I feel like that's a really good way to get involved because it's not cost prohibitive. There are free star charts and maps online that you can find for like one of the different seasons. You can find them like one every day. If you don't have access to the internet, there's usually somewhere that you can go to buy what's called a planisphere, and it's a type of star chart, and you can adjust the time. It's got a couple of different layers to it, and you can spin the different layers to adjust the date and the time, and it'll show you here's what constellations should be out. And then just using that kind of a star chart to go outside and explore the nighttime sky, see what constellations are up, see if you can identify any of the planets that are up, look at the moon phases. Anything that keeps you looking up keeps you interested in what's happening in the night sky. Plus, you never know if you'll see a meteor or a fireball streak through the atmosphere. That's always exciting.
Yep. Well, thank you so much for taking the time and speaking with us today. I think everything you said is great for the students to like look into. And also thank you so much for helping me create the activity that they're doing today in the webinar. So yeah, thank you so much.
Absolutely. My pleasure to help. My pleasure to meet you, and good luck to everybody who's in the webinar here.
So our next speaker is Dr. Rachel Smith. Dr. Smith is the head curator for North Carolina Museum of Natural Sciences Meteorite Collection. She also teaches 2 undergraduate courses that she developed for Appalachian State University and oversees the visual content of the Astronomy and Astrophysics Research Lab, and is currently part of an exciting project to create interactive programs and digital content using new open source Fly Through the Universe software called OpenSpace. Thank you, Dr. Smith, for joining us today.
Thank you. It's great to see you again. And I just want to say good morning to everyone in India. It's 9:30 p.m. here in North Carolina, but this is a really exciting opportunity to be able to reach so many people. So thanks for inviting me to this. Can you hear me okay, by the way? I just want to make sure.
Yes, I can hear you.
Okay, great. Okay, perfect.
Okay, so the first question I had is, astronomy is a really vast field. So what is your favorite part about working in astronomy and astrophysics?
Yeah, so that's a great question. I study the formation of stars, and I'm an observer. So I use big telescopes on Earth, and sometimes an airborne observatory, but most recently on Earth in Hawaii, a big ground-based telescope. And my favorite part of this work to better understand, how stars form, how planets form, and also how our own solar system formed is going to these telescopes and collecting data. And even in a pandemic, we can take some observations remotely. So I've been doing some of that recently. And it's always exciting, even unfortunately not being at the observatory, just being able to gather data and all the information we can learn about the universe from light that we gather from telescopes. Like in your great video in the beginning, you were talking about that, just what we can do as astronomers and as scientists to understand stuff that happened so long ago and how stars are forming today. So my favorite part really is kind of collecting that data now. I think it's very exciting to be kind of getting information that nobody else has, and possibly discovering something new at some point.
Mm-hmm.
So.
Okay, so the next question I had is, when we were talking earlier, we kind of talked about this too, but what got you interested into astronomy, and like, how did you end up in doing astronomy?
Yeah, it's a good question. I kind of took a roundabout course to astronomy. I was always interested in science and always interested in the natural world. So I remember, playing in the dirt and always having, being interested in animals. And I originally wanted to be a veterinarian. So I actually went to veterinary school. And then shortly after graduating, I realized it really wasn't for me. And I love museums and I wanted to do more hard science. And so I eventually found my way to a PhD program at UCLA. And I've always been interested in astronomy. My dad was an astronomer, and we had telescopes growing up. And I always had a fascination with what he did, even though he didn't tell us very much. Some of it he couldn't tell us about. But I just had a fascination with it, and I always kind of wanted to get a PhD and do more actual research. And so I eventually came around to being able to do that. And I feel very fortunate that I can work in a museum, reach a lot of people, be an educator too, and have a kind of this exhibit type of stuff that we do to reach the public and teach students. And I feel like there's a lot of angles that my work can take. So that's been really great.
Yeah, that's great. What do you think is the future of astronomy? I know this is kind of a vague question, but given your work, like,
yeah,
what
I
do
saw you
think?
said that question. I was looking at that question today, and I was thinking, wow, I wonder if she's going to ask me that question. That's such a great question, and it's funny because I'm teaching. I teach astrobiology this semester, and I think I teach my students, these are undergraduates, about interstellar travel in the context of the search for extraterrestrial intelligence and how far we have to go to really explore the stars. And we do this in astronomy with telescopes, but we don't do it as far as our bodies and as society. We haven't gone very far. And so the future of astronomy, it depends really how far in the future you're talking about. I think we're on our way to, we have great missions, going to the planets and going back to the moon. And I think astronomy could exist in space. So our next step might be to build a telescope on the moon, possibly. And I've heard some interesting ideas about that. How to do these things is a little bit, we're always a little bit, I think, behind our ideas in terms of technology and being able to actually carry them out. But I think the near future of astronomy is probably going to be on another planet, possibly the moon, and definite, and at some point Mars. But the far future, who can say? I think we have to be thinking about how much we're going to invest in space and how far we want to really go with the future generations. And if we want to get far and really not only explore, but also learn how to protect our planet and learn how to exist in a sustainable way in general as a civilization, I think that'll also drive the future of astronomy and other sciences. And so it's kind of a big global question of where are we going to go? And I think about this with how there's so much technology we could use to go to space that we don't use for various reasons. And so I think all this technology kind of drives everything and how we decide as a society to advance it and what to advance. So it's a really good question, and it's really something to think about, I think.
Yeah, especially in India, I think astronomy is really big and there's a lot of interest for it. So I think that's good to think about. So to finish off this interview portion, what advice would you give to students who are maybe interested in astronomy or like enjoy astronomy related activities or just looking at the sky?
Yeah, I think definitely going outside and exploring the natural world, looking up. You can do a lot. Just looking at the moon, you can explore. I even take my camera outside and just, with the conjunction of Jupiter and Saturn recently here, we could, I could take a picture or something, just kind of what your previous interviewee was saying, just kind of learning the sky and really just exploring the world. And or exploring your natural surroundings, I should say, just kind of, as much as you can, and asking questions. And as far as in school, I always tell my students, no matter what level they are, to do the best they can. Always do your best, no matter what it is you have to do. And I say this because it kind of goes along with what the previous speaker was saying, is that there's a lot of, science is not about one discovery every day. It's hard work, and it's painstaking work that you generally, once you do it, you love it because you're doing amazing cutting edge stuff. But it's, looking at numbers and coding and staring at your computer for hours on end, sitting on a freezing mountaintop or whatever. And so I would say just always do your best, no matter what it is that you're even asked to do as a student, and always kind of look and see the big picture, and try hard and persevere. There's a lot of failure with success, I think, in every profession. And so definitely don't get discouraged. You always learn something with that. And so I would say just, pursue your dreams as best you can and follow your passion. Like the other speaker was saying, follow what interests you. I had a previous bit of education that I'm not technically using professionally, like veterinary medicine, but I use that knowledge. It's not a waste, right? So you always will gain, education is never a waste, no matter what you decide to pursue. So that's what I would say.
I think that's great advice, especially to keep us like motivated to continue our education and especially during the pandemic. It's good to keep that in mind, I think.
Oh, good. Yeah.
So thank you so much for taking the time to be here today. And
Thank you.
I'm sure everyone is excited to ask you questions that they have during our Q&A session at the conclusion of our webinar.
Great, I'll be here. Thank you.
Thank you. Okay, so our next speaker is Dr. Murthy Gudipati. Dr. Gudipati is a principal scientist at NASA's Jet Propulsion Lab at the California Institute of Technology. Born and raised in southern India, Dr. Gudipati went to several schools in rural villages and urban colleges before receiving Master of Science at the University of Hyderabad, India, and PhD at the Indian Institute of Science, Bangalore. In 2007, Dr. Gudipati joined NASA's Jet Propulsion Laboratory, where he studies the evolution of ices in the universe. Hello, Dr. Gudipati. Thank you for joining us today.
Good evening to you, Meghna, and good morning to everyone in India. The introduction by the director from Patna, I did not get your name, ma'am. Your introduction was fantastic, and Aryabhatta is someone who did outstanding work, and it seems your school is very close to that place where he was born. It's really a wonderful inspiration.
Yep, I think that's amazing. To start off today, there are many people here who may not be familiar with JPL. So what kind of work and research do you do at the Jet Propulsion Lab?
So at JPL, Jet Propulsion Laboratory, what we say at JPL is we do everything under the universe. So we do everything to make it possible to understand the universe. So there is all kinds of jobs there, researchers, engineers. So in that complex set of people who work at JPL, I am a researcher. So we simulate processes that happen on other planets or somewhere between the stars. We simulate all those things in our lab. So we have a laboratory where we do so-called spectroscopy and make this very exotic material and see how this material is responding to its environment. So we predict what happens there, or we explain when some mission goes there or gets data. We explain how that material could be. So that's my work, and I focus on ice. Ice that we all eat. It's really cold, but not with that's no milk, no sugar, just ice. But there are other organic materials that are in that ice, and so we mix these things and do exotic stuff with that. One of the goals is to understand how life has started on Earth. So what happened and when did life start and how did it start? So that's one of the focuses. The other focus is to understand how this ice, it's everywhere in our solar system and beyond, how this ice is evolving and how we can understand whether there could be similar life evolving somewhere else. Those are the questions that we are asking in my lab.
Oh, okay. Wow. So what is your favorite part about working in astronomy and research?
The favorite part is imagine that you're sitting in a magic school bus. You remember? Did you ever read this magic school bus?
Yeah.
The magic school bus, imagine that you're sitting in that and it takes off into the space. And we are sitting in the front seats to look and see how these things are happening. And that is the real excitement. Real excitement is to be in the front seat to be amazed by the universe, by everything that we see. That's what really makes me very excited about it. And also working with a very diverse group of people. That's really nice.
Yeah. So you are also from a rural village in India. You also were brought up in India. So how did you get exposed to and when did you first get interested in astronomy?
So I grew up in a small village, and we used to grow peanuts. When we had the harvest, or even rice. I used to sleep in the fields, and when you sleep there on a clear day, the sky was full of stars. Yeah, it was amazing. At that time, I didn't know what it was. I didn't know what astronomy was. I didn't know even where Milky Way is and how it would look, but I was amazed by that. And since then, I have been really interested in what is happening beyond Earth. But my motivation is actually from the beginning on to understand how, why, and where. The basic questions: how did it happen that we are here? Are all the life forms are here? Or why is the moon there? And why, what are the things that we see in the sky? So essentially, to understand and answer our own conscious perception is nothing but science. And that's what I have been trying to do. And my passion was to understand, to do astronomy as well. Later, it became that I started doing astronomy. In the beginning, I just did normal science, normal education. I was interested in physics, mathematics, and chemistry from the beginning on. I was told when I was going to college that if you take the civics and economics course, you will get very nice bank jobs. I said, I'm sorry, I cannot go for that. I want to do, physics, chemistry, and mathematics. I don't mind not getting good bank jobs. Everyone around me was disappointed, but so I've been interested in science from that point on. Only later part, after going to University of Hyderabad, doing chemistry there in Institute of Science, chemistry and physics. And later on, as a postdoctoral fellow, still physics and chemistry. Much later, I started interacting with a researcher from NASA, Ames Research Laboratory, and that actually took my career path towards astrochemistry, which I really enjoy doing it. So you don't have to start where you want to end up with. You start with what you are very much interested in, what your opportunities are. And as Rachel said, by the way, Rachel, Dr. Smith and me, we collaborate. So we call each other with our first names. As she said, be your best, not be the best, be your best in whatever you do. Eventually you will, if you do that, eventually you will be successful. Give your best, that's it. Take the opportunities that are available. Don't be disappointed if you don't get one opportunity, because one door closed opens 10 more doors. You only have to look for them.
Yeah, I think that like learning about you and Dr. Smith's path to astronomy, it's not always like a linear, a straight path. There's many ways to end up in this field. So to kind of conclude this portion of the webinar, what advice would you give to students interested in astronomy?
Go study STEM courses, learn physics, learn chemistry, learn mathematics. All these things, three things are important for astronomy. You cannot do with astronomy today without learning these subjects. And if you have astronomy in your class, in your curriculum, by all means take it. But you have to build the foundation for your knowledge. Only on that foundation you can build, stronger career path. And so try to learn all the science courses as much as possible. Go to normal education. Go to the college. Go to universities. There are so many excellent universities in India. And then as you start doing this, you can, if you have time, spend on astronomy as a hobby, as like someone maybe building a telescope, or someone may join an astronomy club. Just be fascinated by nature. Ask questions. Never take anything granted. Even if your parents say you are asking too much, or even if your teachers say that your questions are a pain, don't give up. Don't be discouraged. Keep asking questions, and ask the questions to yourself first, and see whether you have the answers. And if you don't have the answers, ask anyone you see, your parents, your teachers, your mentors. Don't let your curiosity be suppressed. Curiosity is the best gift you got, and keep it alive.
That's great advice. Thank you so much for taking the time to be here and talking with everyone today. We are now going on to the question and answer session, and Ms. Anupam will be coordinating the Q&A between students and panelists, and everyone will have a chance to ask Dr. Smith and Dr. Gudipati the questions that they've had.
We would like to start the Q&A. Thank you, Meghna. What you said, Murthy, was phenomenal. Coming from such a humble background and achieving so much and reaching to that height, when students meet people like you, especially from a rural background, you inspire them. You inspire them to a level that even you may not fathom. Like it's phenomenal. Thank you, Meghna, for bringing us such constellation of stars, I would say, in the field of astronomy. For somebody out here who's studying in a government school, we never get this kind of an opportunity to actually see with our eyes. Sometimes I feel, was Corona ever a curse? I think it was more of a boon. and the entire world has come together, and we are collaborating to get our questions answered. Today is a great day when we have all of you here. And I would like to first request a student from Zilla Parishad High School, Kaza, Andhra Pradesh. She's a smart girl studying in 10th grade. Her name is Pooja Pamarthi. So may I request Pooja to ask her first question? So here we have Pooja. Can we have Pooja online? Pooja, go ahead.
I would like to ask, what are black holes?
Okay. Who would like to take up this question? Dr. Gudipati or Dr. Smith?
I think Dr. Smith, because she's an astronomer, real astronomer, but I can give later a little bit more anecdote.
So it's funny. Thank you for your question. So I study something so far away from black holes, but this is a question we get a lot, is people want to know about black holes, which actually I'm not. Murthy may know more about black holes than I do, in fact, at this point. So black holes, well, we're learning about black holes, actually. They are when a massive star, a huge star, much, much more massive than the sun, when it dies, essentially, it will supernova, so it'll explode, and then it will become a black hole. But we're talking about many, many millions of times more massive than the sun. And then this is a region where it's a huge, it's the center of all the galaxies. There's a supermassive black hole in the center of every galaxy we think. And there are other regions of the universe where there are black holes. The reason they're hard to study is no light can escape a black hole. But we're learning, there's some really amazing discoveries now where there's actually an image from a few years ago of the what they think is basically the edge of the black hole. So it's called the event horizon, and it's just past that edge where light can escape, and you can see this kind of ring of energy, which they transform the data into visible light, so you could kind of see it. But it's this huge gravitational region that light can't escape. And what I love about black holes, well, actually, talking about inspiration too, is that science fiction has taken a great lengths to explore black holes and wormholes. And so we don't really know necessarily what happens when something falls into a black hole. And so there's a lot of imagination out there in terms of movies and other science fiction to try to explore that. But they're real. We don't know, we can't see them directly, but you can think of them as huge, big gravitational places where a star has died, and they're so massive that not even light can escape them. I don't know if Murthy wants to add anything to that. Feel free. Again, I'm not a black hole expert, but
same thing here too. I'm not an expert on black hole either. A couple of general points is that matter's density is one thing that we can feel. For example, if you have a rock that is more dense than if you have, let's say, an apple or a fruit. And imagine that the density increases, but not the size increases. So we have a huge amount of density. And then the gravity of that dense material becomes extremely, different than what we are used to. Interestingly, so black holes are from very, very, very high dense, matter, which has not the form that we know existing there. Interestingly, black hole research was actually brought into a very important, turn point by one of the Indian-born scientists, S. Chandrasekhar. And on his, he got a Nobel Prize, and before he got his Nobel Prize, two of his students got Nobel Prize. And on his name, NASA has actually one of the X-ray astronomy telescope named as Chandra. So, black hole research is very much a part of some of the outstanding theoretical scientists. And we still don't know much about black holes. At least I don't know much than that, what I explained right now. I may be wrong.
Thank you, Dr.
But
Smith.
not about Chandrasekhar. With Chandrasekhar, I'm right.
Thank you, Gudipati. May I now request our next student? Her name is Ashrita. She is from 10th grade from the same school. I would request Ashrita to ask her question.
I want to know about the Haumea dwarf planet. The host here.
About the dwarf planet. Okay. She wants to know about what are dwarf planets.
Okay.
What are what? I'm sorry, I didn't understand. Oh, Murthy's going to take it. Okay.
The question is, you want to know what are dwarf planets? Is that correct?
Haumea dwarf planet.
Telugu Adugu.
Telugulo అడగమ్మా పర్వాలేదు.
హౌమియా డ్రాఫ్ట్ ప్లానెట్ గురించి తెలుసుకోవాలనుకుంటున్నాను సార్.
హౌమియా అంటే ఏంటమ్మా? హౌమియా అంటే okay. That is that is not a dwarf planet, I think. See, Pluto is called a dwarf planet, but there are people still debating. Can you spell the name that you said? Which is the dwarf planet?
Pluto, I think.
Yeah, okay. Pluto, okay, good. So Pluto is called a dwarf planet by some astronomers because it does not, its size is different. It does not have the same, characteristics of a normal planet, and it looks as if another definition for dwarf for planet is that it should have a moon going around it. So because all these things were not there and it was too small, some astronomers said it should not be a planet. Some other astronomers say no, Pluto is a planet. So officially right now, it is not a planet, but a dwarf. That means, small planet. One of our best, science colleagues is working on this, and he and other people say, no, Pluto should be a planet. The question is still not resolved. Scientists are debating whether it should be a planet or not a planet. I tell people, how does it matter whether we call Pluto a dwarf planet or a planet? Pluto is Pluto. It is such a beautiful, almost like a sphere. And it has so much of beautiful geology. It doesn't matter what we call that. That's what I feel right now. Okay?
Thank you, Ashrita, for your question. I would now like to invite.
I want to make another question, ma'am.
I'm so sorry, Ashrita. We have about 10 students waiting. So please wait for your time. Let those questions asked, then we will come back to you. We have Sheikh Ali from the same school, studying in 8th grade. And he would like to ask you a question. Sheikh Ali.
Before Sheikh Ali asks his question, I would like to congratulate President Andhra Pradesh to participate in the annual National Level Science Congress next month. Congratulations, Ali. You can go ahead and ask your question.
Thank you. గురుడు మీద హెలియం ఉదజని వంటి విషవాయువులు ఉన్నాయి అంటారు కదా. పూర్వంలో మన భూమి మీద కూడా అలాంటివి ఉన్నాయా? మనం అటువంటి ప్రదేశంలో జీవించగలమా? లేదా అటువంటి ప్రదేశాల్లో మన మొక్కలు అటువంటివి బతుకుతాయా లేవా?
Okay. I think I understand what he's trying to say.
Sir, can you please repeat the question in English so that everybody else from this part of the country can understand the question?
So I think he's asking let's see, what is that? Gurudu. What is the
Jupiter.
Jupiter. Okay. So Jupiter has a lot of poisonous gases. So do you think that Earth also had similar poisonous gases earlier? And do you think whether we can live on Jupiter in those, or whether plants or anything else can thrive? Rachel, why don't you go ahead and tell them what you think?
Thank you, Murthy, for allowing me to answer about. So that's a good question about Jupiter. Jupiter is a gas giant planet, so we cannot live on Jupiter for the main reason that there is no surface on Jupiter to live on. So it's really just a ball of gas. And the composition of the gases, Murthy might know more than me about the exact composition, but I actually haven't really considered Jupiter as a habitable planet so much because of the fact that there's just nowhere to go on Jupiter. Sorry? Oh, and anyway, so as far as other planets, when you think about gases and our own planet, I think more of Venus, because Venus is very, very hot because it has sulfuric acid clouds. It has CO2 in its atmosphere. So these are called greenhouse gases. And they're gases that build up in an atmosphere to the point where heat cannot escape. And so we look at Venus as sort of what could maybe happen to Earth if we keep pumping gases into our atmosphere. But so that's sort of a warning type of planet that we don't want to get Earth to that point. Right now, the closest habitable planet, I'd say, where we're actually going to send astronauts next would be Mars. But the reason Mars is not habitable yet, you can't just walk out from your spaceship, is because there isn't enough of an atmosphere. There isn't oxygen. There isn't an atmosphere to hold water on the surface of the planet. And so what we have to do with Mars to be able to really live there is something called terraforming, where you actually create an atmosphere like Earth so that water could exist on the surface. And this is something where we don't know how to do it, and it may be impossible, but that's kind of the future of living on another planet, possibly. But right now, there is no other planet except Earth where we can actually live outside without any problem. Murthy may want to add to this.
Yeah, one thing is, I think the planet he was talking about was actually Venus, because Jupiter is called Sukragraham, not Buddhagraham.
Okay.
So
I covered Venus. Good.
Exactly. Yeah. So one last thing is the conditions on Earth, how they were for life. Very interestingly, very early in our solar system formation, there was one time where there were a lot of asteroids and comets scattered around, and then they were pounding on Earth after Earth and Moon were formed about 4 billion years ago. it seems soon after that, the first life has started on Earth. So the conditions that were appropriate for life to start were already there 4 billion years ago. So long before our life has started. So first bacterium was already detected from that time. So Earth has had livable conditions for longer period of time. So it probably was very soon habitable as soon as it was formed after a few hundred million years after that.
Thank you.
Govinda? Okay, so go ahead. Thank you.
Thank you, Dr. Thank you, Gudipati, for your answer. Now, may I request Nishma Chandrika, a 10th grade student from Jila Parishad High School, Kaza, Andhra Pradesh, to ask her question. Chandrika. Can we have Chandrika now? Yes, we have. Please go ahead, ask your question.
I think you are still on mute.
Yeah, Gudipati, I think she would be asking her question in Tamil or Telugu, so you may have to again translate.
Yeah, no problem. Yeah. I think she's muted. She should unmute herself.
Unmute Jay.
Can the administrators? Yes.
Now she is.
Yes. Yes, can you ask your question, please?
I want to know about the galaxies.
Which galaxies?
The galaxies in the atmosphere.
So, Rachel, you can tell them how many galaxies we have and how far they are,
Sure.
something like that.
Okay, yeah. So galaxies are basically huge groups of stars that are bound together. And we have, the estimate has changed. It used to be about a few hundred billion, so like 400 billion. But now from Hubble, as far as I know, it could even be as many as 1 trillion galaxies. So many times more than that. So they basically think of them, and within each galaxy is several hundred billion stars, and each star, we think, has at least one planet, at least in our galaxy. So there are many, many possible planets out there. We're learning about how many Earth-like planets there are, but there are so many possibilities of planets and different systems other than Earth all throughout the whole universe. And so, does that answer your question?
Yeah, I think, when Dr. Smith is saying billions, think about it, or you take a paper and write 9 zeros, and then on the left hand side, 1. That is a billion.
Yes, thank you for clarifying that.
So each galaxy has so many stars, and we think that we have more than so many galaxies in the universe.
Wow. Such a intelligent way of putting across the numbers, Gudipati. That was brilliant. May I now request students from Bihar who are studying in various government schools, as well as who are also studying in Jaipuria school, to ask their question. May I now request our coordinator to make Atisha Gautam, who's a student of Standard 7 studying in Jaipuria school, as a panelist. Atisha Gautam. Please go ahead and ask your question, Atisha.
Good morning, everyone. My name is Atisha Gautam, and I'm currently studying in class 7, representing my school, St. Emma Jaipuria School, Patna. Ma'am, may I ask a question to Mrs. Rachel Smith?
Hi, yes, please. Hello.
My question is, why are we unable to see the gravitational force?
Why are we unable to see the gravitation? That's a really good question. Yeah, it's an invisible, we can measure it, but we cannot see it. Well, I guess that's a good, no one's ever asked me that. That's a great question. The reason I would say is we have a limited, when you say see, do you mean with our eyes or with in general?
With eyes, we can.
With our eyes, okay. So so the way to think about what we can see is very limited. We have a very small range of what we can see. Like think of a rainbow, for instance, like light that we can see. And there's so much more energy, really. Light is energy, basically. And so if you think of it as a window, and then all beyond that, on either side, are all these other wavelengths of energy that we actually need instruments to help us see. And so we use telescopes and we use instruments to try to understand these different bands of energy that then tell us about forces and about matter and about objects that we can't see with our eyes. But yeah, that's a really good question. It made me think a second about gravity. I don't usually think so much about it, so that's a great question. But does that make sense? Does that answer your question? Okay.
Yes.
Okay, good. Thank you.
Thank you, Atisha, for that smart question. May I now invite Kajal from Kant Madhya Vidyalaya. She's studying in a government school to ask her question. Madhya Vidyalaya student, do we have her online? Yes, she's there. आप अपना सवाल पूछ सकते हैं. अगर आप हिंदी में पूछना चाहते हैं तो पूछ सकते हैं, हम उसे ट्रांसलेट कर देंगे. Okay, by the time they, perhaps there is some connectivity issue in the government school, can we invite our next student, Arab Arya, from Standard 8 of Jaipuria School to ask his question. Arab Arya from Standard 8. Yes, Arab, you need to unmute yourself and yes, okay. So.
Yes, ma'am. Good morning, everyone. I'm Arab Arya from Standard 8A, representing St. Emma Jaipuria School, Patna. Ma'am, may I ask a question to Dr. Rachel Smith?
Yes, please, go ahead. Hello.
My question is time travel really possible in future?
Oh, I love that question. So is time travel possible in the future? Will it be, so according to Einstein's equations, we can only potentially travel forward in time, not back in time, mathematically. And there's some question as to maybe you could use a wormhole. Stephen Hawking had some ideas about that to go back in time, but really using the mathematics from Albert Einstein, we can only go possibly forward in time. And the way that would work is if we could travel very, very fast, getting very close to the speed of light. So if you could travel, say, I mean, we travel a tiny, tiny fraction of the speed of light now using rockets. But if you could go even 50% of the speed of light and then get even faster, and you go far away with your rocket that far and come back and go that fast coming back as well, time will actually go slower for you on the ship than it will on Earth. And so when you come back to Earth, people and the whole Earth would be much older than you would be, depending on how, and to a degree of depending on how long you were in the ship. And that's because time is relative to the observer and to the person, it's relative. So if you're on the spaceship traveling very, very fast, go very, very far, and we're talking very huge astronomical distances, and come back, then your experience of time is actually going to be different on your body and in your mind than the people who didn't travel that fast on Earth. So that in that way you could go forward in time because you'd come back to a future Earth. And this could apply to actually also traveling very close to a black hole, because when you're very close to that gravitational pull, time goes slower for you. And so you see this in there's a movie called Interstellar, which I don't know if anyone would have seen, but they show this in the movie, and this is actually real. These were models that an astronomer at Caltech named Kip Thorne advised on this film, where it's actually mathematically true if we had the technology that 30 years could pass on the ship by the astronaut waiting, and the people who went to this planet near the black hole, only a few hours passed. And that's a whole strange way of being, but it really seems to me, I'm very excited about that possibility. And that's why I'm always excited to talk about the possibility of future technology, using this technology to get far in space, because we should, I think, try to make this work. It sounds kind of exciting to me. I don't know. So that's the only way I know. Yeah.
I want to just add one thing, a pinch of reality here is, as we start traveling close to the speed of light, we cannot have our mass. Mass cannot travel at the speed of light, okay? That means humans will not be able to reach anywhere close to that. And that's one thing one needs to do some research and find out. Science fiction is good, but science is better.
Well, it's not, I'll just point out to Murthy, we're not talking at the speed of light. You can never go as fast as the speed of light and have mass. That's true. I'm talking close to the speed of light, 90%, 80%. Now we're talking really, really fast. You can still have mass at that speed, but not at the speed of light. Nothing can go as fast as light. So I just want to make sure that was clear. We're talking, even if you could go 50%, 80%, 90%, you're talking, this is where time travel happens if you return to a place that will be older than when you left. So you're correct about that, but you're not 100% the speed, but we don't even need to get there. Anyway, good. Thank you for that question.
Thank you so much. Thank you, Gudipati, and thank you, Dr. Smith, for your answer. Thank you, Arav, for joining us today. May I now request students from Balak Madhya Vidyalaya, or can we have Sudama from Kumrar Madhya Vidyalaya? Okay, I think there is a connectivity issue at that school as well. May I now request Kumar Adityam? Is he available? Kumar Adityam from Standard 8th grade, Jaipuria School. Kumar Adityam, Standard 8, Jaipuria School. Please go ahead, ask your question. Adityam, you need to unmute yourself and start your video. Yes.
Yeah, ma'am. I'm audible, ma'am. Yes. Okay.
Yes.
Good morning, everyone. I am Kumar Adityam. I am currently studying in Standard 8, and I am representing Set MR Jaipuria School, Patna. Ma'am, may I ask a question to Dr. Rachel Smith?
Please.
Ma'am, how do dark matter and dark energy affects the universe?
Yes, great question. Okay, dark matter and dark energy. So we're also just learning, astronomers in general, about dark matter and dark energy. And we don't know a lot about these, whatever makes up dark matter and dark energy. But the way I understand it, well, first of all, most of the universe is dark matter and dark energy. What we are, matter, is a very small percent, maybe it's like 4% of everything in the universe. And then the rest is dark matter and dark energy. Dark energy is something that has to exist to explain how matter behaves on a big scale. And so by studying galaxies and black holes, we'll learn about what that is. It sort of kind of like binds the universe in some way. I don't think we know exactly what that is, though, or what dark matter is, but we know that there has to be this much matter and this much energy in the universe to explain how stars and planets and galaxies are behaving. And so we know that there's all of this stuff that's dark or invisible, that's why we call it dark, to explain the behavior of all the stars and galaxies that we see and the expansion of the universe. So the universe is expanding, is accelerating in its expansion. And the way to explain that is dark energy. And so, but yet what that is, we don't know what that is exactly. And Murthy can add anything he'd like to that explanation, but that's pretty much what I know about it. It's a really interesting concept, actually, and we'll learn more about what dark matter and dark energy are, but it's sort of a process of elimination, that there has to be more out there to explain all the phenomena that we see. And so scientists are...
Again, I'm not an expert in this, definitely. By the way, one more thing that I want to say is any opinion or material that I'm discussing is my personal opinion, and it's not the opinion of NASA or JPL or Caltech. Okay, keep that in mind. Don't say that NASA said this or JPL said this. No, Murthy Gudipati said this. Okay. With that, for me, dark matter and dark energy is one of the biggest puzzles of modern astronomy. We do not know how they should look like, whether whether it is there or whether it is not there. Sometimes I say that maybe the calculations may be wrong, but I wish that is as simple as that. It may not be. So we have, right now, as I understand, we have no idea how they should look like, how the dark energies look like, dark matter should look like, what their properties are. Okay, that is for you, the future generation, to do research on.
Thank you. Thank you, sir.
Thank you, sir.
Thank you, Aditya, for your question. May I now invite Aditya Kumar, who is currently enrolled in 9th grade, to ask his question. Aditya.
Good morning, everyone. I am Aditya Kumar from Standard 9, representing the MR Jaipuria School. Ma'am, may I ask a question to Mr. Murthy Gudipati?
Yes, please.
So my question is that, does the movement pattern of planets really affect us?
Can you repeat, please?
So does the movement pattern of planets really affect us?
Does the movement of planets affect us? Like,
that the movement of... Yeah, I didn't get it still. Anyone has understood it?
I think he's asking, like, astrology, does the movement of the planets affect us?
Like in India, there is a great understanding that the movement of the planets affect us. So
like astrology.
Yes, as
so
astrology.
Are you talking about astrology?
Yes.
Are you asking about astrology? Let him confirm that.
No, sir. My question is that, does the movement pattern of planets really affect us?
So movement affect us in which way?
As geologically or climatic conditions.
Okay, so he's not talking about astrology. That's what I want to make sure. Okay, you're not talking about astrology. And movement of the planets, for example, the Earth Moon gravity is in fact shown. Its effect is in the tides. On a full moon day, if you go to ocean, it has big waves. That's because of gravity. Okay, so there is a gravitational effect within our solar system, definitely. But the farther the bodies are, or the planets are, the weaker is the gravity. And also, gravity is determined by the mass of the planets. So if you look at it, our biggest gravitational pull is by the sun. Sun is the highest or biggest mass there. And then next gravitational pull is moon. Moon is closer to us, okay? And the rest of the planets will have a secondary and tertiary perturbations on these gravitational pulls. That's a very interesting and very important question. At times I used to think, very recently we had Jupiter and Saturn in one direction, right? So they are aligned. Imagine if all the planets are aligned in one direction. Will there be a serious effect on Earth? I don't think so, not much, because the sun is here. It's like, this is the biggest weight here. Even if rest of them are like that, there may not be a serious effect on our planet. That's what I think. It will be only small perturbation. My opinion, yeah.
Thank you, Gudipati. Thank you, Aditya, for your question. May I now request our science teacher from Jaipuria School to ask his question. Mr. Chandan.
Thank you, ma'am. Good morning. Good morning, everyone. I am Chandan Mishra, science teacher at Seth MR Jaipuria School. May I ask a question from Dr. Murthy Gudipati?
Yes, please. Go ahead.
Sir, how quantum physics is related with astronomy? Because as a science teacher, how will we able to deliver the concepts of quantum mechanics easily to the students? Because this is a very abstract thing.
A very good question. The one thing is I think I worked on, I did a little bit of my research or studies in quantum chemistry earlier. So think about this. Bohr's atomic model is nucleus, and then the electrons are rotating around the nucleus in orbits. Okay, and each one has certain energy. And based on the energy, these orbits are determined or defined. And it is exactly the same as a solar system, for example. So solar system has different forces there, not the negative charge and positive charge, which is the Coulombic force in an atom, which then, atomic motion, the subatomic particle motion is determined by quantum physics. Whereas in a solar system, it is determined by gravitational forces. And the planets that are closer to the sun move faster. Otherwise, they get captured in the gravity. And the planets that are farther away from the sun, they move slower. So this is the best analogy between quantum physics and astrophysics, at least to my easy way of explaining. Does it answer your question?
Yes, sir. Thank you so much, sir, for answering my question.
Ms. Anupam, I think you're muted.
May I now request Amisha from Jaipuria School. She is our social studies teacher. She would like to ask a question as well. Amisha, ma'am, please go ahead.
Good morning, everyone. My name is Amisha Sharma, and I am a geography teacher at St. MR Jaipuria School, Patna. Ma'am, my question is to Dr. Murthy Gudipati. May I ask my question?
Yes, please. Can you please go close to the computer so that we can hear you louder? Yeah, thank you.
Is my voice audible
now? Perfect.
Sir, my question is that there is a general conception among people that in the field of astronomy, we have career options like a scientist and a researcher. But what are the other career options we have in this field, and how we can train our students towards this direction?
Excellent question. See, astronomy or space sciences is a very complex, multi-directional, multi-dimensional endeavor. So scientists and engineers become the big part of it. But you can, if you want other, you can have artists, for example. You know, one of the fantastic outcome of art is the origami art, and that is now implemented in space missions. Okay, only thing is for non-science, non-engineering career paths, the opportunities may not be as many as for scientists and engineers. In fact, for scientists, the opportunities are far less compared to engineers. You know, whether it is NASA or whether it is ISRO, they have very high demand for engineers and some scientists. And as I said, I don't think that you know, anyone who is studying accounting or for you know other career paths would be having more opportunities in astronomy or space sciences than what they have outside. For example, if you look at a hospital, how many accountants are there? Very few. Okay, there are many doctors and nurses and things like that. Same thing with the spaces also. Does it answer your question?
Yes, sir. Thank you, sir. Thank you very much. Thank you, ma'am.
Rachel, do you have anything you want to?
I was not. I was at it. There was a technical issue, so if you could repeat the question, Murthy, and let me know, or someone, and I can add something. I'm sorry. It was something about opportunities for scientists versus engineers.
Non-scientists and engineers.
To work in science or work in the field.
In astronomy or space.
Well, I mean, I work at a museum and a university, and I'll just say science communication is a very big part of an important aspect of what we do. And, you know, having people who have a knowledge of astronomy or knowledge of any science really, because there are lots of different disciplines in the museum, help communicate with the public, help us do that in a lot of ways. And just in general, I think across the world, communicating science in some way you know, is very important. And so I would say a non-scientist, just having knowledge of science and being a communicator is very good. As far as exactly what job that is, I'm not sure I can really answer that beyond what I know here. But I think that that's how I would answer for a non-scientist right now. I think Murthy can speak a lot about what at JPL, you know, engineers versus scientists. I heard that part. So so that's all. That's what I would add. Does that help? Sorry, I hope so.
Yeah, I think so. I think it was good. Yeah.
Okay.
Thank you, Misha ma'am, for your question. We are now almost ending to the end of the workshop. We have 5 minutes to go. So I would like Meghna to take up a few questions that you may have chosen from the chat box, and please ask the panelists.
Yeah, so Apurva had a question. What kind of mathematics is needed for theoretical astronomy?
Everything.
Yeah.
Basic mathematics. There's nothing like, it depends upon if you're going to, you know, bachelor's, master's, then you narrow down. Right now, learn everything.
And theoretical, I would say knowing math is very important to have a quantitative mindset, but really it's coding. You know, you need to be good at modeling. If you're going to be a theoretical physicist or astronomer, you need to be able to create these models, which is basically computer coding, and learning how to do that in whatever language you can, And once you can code in one language, generally there's some kind of translation to being able to code in other languages. But I tend to think of less very advanced math, like, that you think of for people who just do math for a living, but actually being able to have really good coding skills as well as a knowledge of the science. That to me is really critical, not just for theoretical, but also for observational. We have codes for everything. Murthy uses codes too. And so it's, I think computer coding is a very important aspect of all of this, for sure. So.
Okay. One more question we have from the chat is Vinayaka Shankar asked this question. Why do planets only revolve around their orbit? Why do they not exchange places with other planets?
Oh, we think they actually did migrate. There are models about that. There's several models that you can research. One is called the Nice model. It's spelled Nice. It's for Nice, France, where it originated, and it talks about planetary migration. Right now there isn't a single model that actually explains the entire solar system, including the Kuiper Belt, the comets, the asteroids. But the Nice model is one model that I know of. There are others that actually talk about planet migration. So we don't think that all the planets really formed exactly where they are. Why they migrated out, those are questions. There was a lot of dynamics happening in the early solar system. There was a lot of more material out there, a lot of the debris from the formation of the planets that now we see as the asteroids and comets. So we don't see. So basically, the answer is they have migrated. And was that the only part of the question? Sorry, it's
yeah, I think that was essentially what the question was asking. Because we're coming short of our.
Sorry, I was going to say, if Murthy wanted to add to that, the models of planet migration, I don't know how much of his work relates to that, but.
Planets migrated, but they don't migrate so much now. They may be still motion. Once upon a time they migrated, and we think that could be one of the reasons why the material that was needed to kickstart life was delivered to Earth. So good that Jupiter and Saturn were fighting with each other. So that was the reason why we are here now. That's one thing. And second thing was there were 2 or 3 times in the evolution of Earth that there were big asteroids and comets that hit Earth. And that also contributed for humans to evolve in the evolutionary process. So it is a very interesting thing. Yeah.
Okay, so because we are running short on time, this will be the last question we're taking from the chat. All the questions asked are great, but the last question was asked by Parul Barnwal. And what will happen if the moon is destroyed?
Oh, wow. Well, let's hope it isn't. Well, the moon is destroyed. I'm not sure how they're thinking, but I'll just say a lot of negative effects could certainly occur on Earth. The effects of the tides. Our tides are really governed by, or the result of the moon's pull. So those would go away. We'd probably have, the moon actually keeps us in a fairly stable climate. We think the moon is really important for habitability on the Earth, for climate stability. It's a very large moon for the size of Earth compared to other planets and their moons. So I would imagine that if the moon just suddenly vanished, we would have a lot of climate issues very quickly. The moon is migrating away. I think it's 2 centimeters a year or something like that. So at some point in the far future, we will eventually, if we last the billions of years that we hope, we won't really have the moon the way we see it now, and possibly the effects on Earth will be different. But yeah, we need our moon for sure for stabilizing the Earth. That's my understanding. And Murthy, you can probably speak something to this. No? Okay. No, he says no.
The thing that I want to say is that once a very crazy scientist called Edward Teller said that we should go and blow the moon away so that we will not have any seasons. I think we don't know what the repercussions would be if we don't have moon. But we do know that having moon is such a beautiful thing that we have tides, we have full moon day, and we can watch moon. There's so much of poetry about moon. So don't worry, moon will be there for a long time.
Yeah, I don't think we're going to get rid of it anytime soon. So yeah, but we need our. We cannot. Well, I think hopefully we cannot. But yeah. Great question.
On that note, we'll start our closing. Unfortunately, we weren't able to get to all the questions, but I saw that Dr. Smith and Dr. Gudipati.
We cannot hear you.
Now we can. I think first few seconds you're a bit faint, and then you get louder. I'm not sure why, but.
Can everyone hear me?
A little muted. You're a little low. I'm not sure what the reason is.
Okay.
That's good.
Okay. So unfortunately, we were unable to answer all the questions from the chat, but because of time, we will be closing now. So thank you, Dr. Gudipati, Dr. Smith, and Jaipuria School for collaborating with the government schools. Thank you, Zilla Parikshit High School, Kaza, and thank you to the parents who allowed their wards to participate in this event, and to the teachers who conducted the week-long pre-workshop session. Last but not least, thank you to the technical support team of Jaipuria School, who facilitated this webinar and workshop successfully. I'm hopeful this interactive virtual workshop, webinar, and responses from our panelists have inspired and addressed your curiosity about the vast field of astronomy. I hope this experience will inspire you to reach for the stars in your aspirations and continue your educational journey.
Yeah, wonderful. Don't hesitate to reach us out. You can find me and you can find a way to reach me. Provided you have a serious question, we will always respond.
Yeah. That's great. Thank you, Meghana, too, for arranging this. This is a really fun opportunity, and it's exciting. I've never done anything really like this, so it's really nice to have this reach, I think. So thank you for having me.
And
good.
And director from Patna, ma'am, you have done an outstanding job. Thank you also. It's really good.
Thank you.
Yeah.
Thank you. Thank you so much. Thank you, Meghna. Thank you, Dr. Smith. And thank you for being with us and coming to the land of the Aryabhata and adding to the wonderful knowledge that our children have. People like you make this world better. Thank you.
Thank you.
Thank you, Ms. Anupam.
Thank you.
Thank you.